All right, today we're going to tackle something that, super important but maybe a little mysterious to a lot of people, the ASNT SNT TC-1A standard. This thing is basically the rulebook, the blueprint for how we qualify the experts who keep our bridges, planes, and power plants from failing. We're going to walk through it step by step.
But first, let me ask you a question. How in the world do you find a crack that's smaller than a human hair inside a solid piece of metal on a jet engine without cutting it open? It sounds impossible, right? But the answer is the key to pretty much all of modern engineering and safety.
The answer? It's this incredible field called non-destructive testing, or NDT for short. Seriously, it's like giving engineers and technicians actual superpowers. They can see inside materials, find problems when they're still microscopic, and get them fixed long before they become catastrophic failures. And the best part? They do it all without leaving so much as a scratch.
So here's the game plan for our journey today. We're going to start with why certification is such a big deal. Then we'll look at all the different cool methods you can specialize in. After that, we'll climb the career ladder, see what it actually takes to get qualified, and finally, look at how you stay at the top of your game. All right, first things first. Why do we need these intense, formal certifications? I mean, this isn't just about collecting certificates for the wall. It's about building a foundation of safety and trust that, honestly, we all depend on every single day, whether we realize it or not. Think about it. When an NDT professional inspects a critical component and gives it the green light, that judgment has to be absolutely perfect. The SNT TC 1A standard is what guarantees that everyone with that power has met the exact same high bar for knowledge and skill. It's the bedrock of reliability in industries where failure just isn't an option. Okay, so if you're starting a career in NDT, your journey begins with a choice. See, there's not just one way to do this. There are tons of different methods, and each one is a unique tool for a specific job. This is where you pick your superpower. And wow, just look at this page from the standard itself. It shows you the sheer variety we're talking about. You've got everything from shooting sound waves through steel to using high-powered X-rays. The most common specializations you'll hear about are things like radiography, ultrasonics, and magnetic particle testing. But there are so many more.
Let's make this totally real for a second. Imagine your job is to inspect a brand new weld on a massive oil pipeline. You can't see what's going on inside that weld. So what do? You bring in radiographic testing, or RT. It's basically a super-powered X-ray that lets you peer right through the steel and spot any hidden flaws.
Okay, but what if the problem isn't deep inside? What if you're looking for a tiny, almost invisible crack on the surface of a steel part? For that, you'd probably use something called magnetic particle testing. You run a magnetic current through the part and dust it with tiny iron filings. If there's a crack, the magnetic field leaks out, and those particles gather right on the flaw, making it pop out plain as day. Pretty clever, right?
Okay, so you've picked your method. What's next? Well, now you start climbing the ladder. The NDT world has a very clear path for progression, taking you from a trainee just learning the ropes all the way up to a true industry expert. It basically breaks down into 3 key levels of qualification. You start out as a level 1, who is the hands-on technician. After you put in the time and training, you can move up to level 2, the inspector. And at the very top of the pyramid, you have the level 3, the expert. And the jump between these levels, it's huge. A level 1 technician is really skilled at following a precise set of instructions to perform a test and record what they find. But a level 2 inspector has a lot more responsibility. They're the ones who can actually set up the equipment, interpret the results, and make the critical call on whether a part passes or fails. They also start training the new level 1s.
And then you get to level 3. These are the absolute gurus of the field. A level 3 isn't just following the procedures. They are literally writing the procedures. They decide which NDT methods to use for a project, interpret all the complex codes and standards, and they're the ones trusted to train and certify the level 1 and 2 personnel below them.
So how do you actually climb that ladder? Well, it's not easy. You have to run what's basically a gauntlet, proving your worth through 3 core pillars of qualification. You can't be good at just one. You have to master all 3.
It really boils down to these 3 non-negotiable things. You need formal classroom training, you need a massive amount of documented on-the-job work experience, and you have to pass a series of really tough written and practical exams. There are absolutely no shortcuts. And this table here really shows you what that looks like in practice. Let's take a common method, liquid penetrant testing. To jump from level 1 to level 2,
You need another 8 hours of formal training, plus another 140 hours of documented experience in the field. Every single step up requires more investment. And for some of the really complex, high-tech methods, the numbers are just staggering. Get this, to become a Level 2 in neutron radiographic testing, you need to log 1,680 hours of on-the-job experience. Let that sink in. That's a massive commitment.
And then you've got the exams. This is a whole other level of challenge. You have to pass a general exam on the science, a specific exam on the company's procedures, and a practical exam where you prove you can actually do the work. Oh, and you also have to pass vision tests to make sure you can actually see the tiny flaws you're looking for, and it's all closed book. No cheating, you have to just know it.
And what's interesting is how standardized this is. You can see here that for the general exam, it doesn't matter if your specialty is magnetic particle or ultrasonic testing. You're facing a tough 40-question exam that covers the core principles of your method. The bar is set high, and it's set high for everyone.
And speaking of a high bar, check out the passing grade. You need an average of 80% across all your exams to pass, and you can't get less than 70% on any single one of them. There's almost no margin for error, and that's exactly how it should be when safety is on the line.
All right, so you've made it. You've climbed the ladder, you passed the exams, you're a certified expert. You'd think the journey is over, right? Nope. In a field that changes as fast as this one, getting certified isn't the end. It's an ongoing commitment.
This is not a one-and-done kind of thing. Every single NDT professional, from level I all the way to level 3, has to get recertified on a regular basis. The longest you can go is 5 years before you have to prove your skills all over again.
And the reason for this is pretty straightforward, right? Technology doesn't stand still. New materials are invented, techniques get better, and standards evolve. Recertification makes sure that an expert's skills aren't just something they learned a decade ago, but that they're sharp, current, and ready for whatever new challenges come their way. So this really leaves us with one big, important question. These standards are what keep the modern world safe. But as we invent even more complex machines and revolutionary new materials, the real challenge will be, how do these standards and the incredible professionals who uphold them keep evolving to make sure our future is just as safe as our present?